Hello. In this video I would like to give some advice to new and young scientists in physics, to new also students who start to learn chemistry and learn physics in their universities. So, first of all, if you start to study physics, or if you start to study chemistry, physical chemistry particularly, you should learn as many branches of science as you can. You should try to comprehend everything your brain can take inside. Because of you cannot make a great discovery, you cannot make a great invention without deep and systematic and complex knowledge in physics. The second point, you should hurry. Because only until you are 30 years old you have quite good chances, quite good odds to discover, to make something important in science, to make an impact. Also, third point, you should have passion, because if you have passion to discover, to learn physics, to learn chemistry, then it motivates you, and it gives you this power to comprehend, and to you feel like a warrior who fights against nature and its secrets. The fourth point, you also should understand that you are not in better conditions than, for example, the scientists of 19th or 18th century. Those scientists of those previous centuries, they were aware that all the information that they accept in their brains and they read in different scientific works, this information can be false. There could be pseudoscience that come from the Middle Ages, some wrong, totally, absolutely wrong ideas in the sources of information that they consume. So, you must be also aware that you are not in better conditions, that because of modern physics, it's a very wide branch of knowledge. It's very many different spheres and domains of explorations and investigations. So, and also many people who speak different languages are involved in this process. So the chances for mistake, is higher than before, not lower. The fifth point is that if you study modern physics and modern chemistry, then you should be aware that even in its like outer structure, even in its form, the modern physics is not yet a science, because here is the explanation. There is no scientific structure or hierarchy, official hierarchy of physical laws. That is, there is no one global, general, official classification of physical phenomena, of physical effects, and there is no list, for example, which can show us that this phenomenon, this particular phenomenon, is caused by this law number 1, by this law number 2, by this law number 3, and so on. So everything is quite meshed and mixed, absolutely with no system and scientific attitude. That is, there is no official edition, no official source of information, for example, Codex of Physics, Codex World, Codex of Physics. which we can rely upon. For example, in this book, if such book existed, should be a codification. There should be parts and articles, and also every definition, definition in physics. For example, what is matter, what is energy, what is time, what is space, is strictly scientifically determined. And also we can see the date of the last edition and mutual links on of these physical terms that are used in other chapters, in other parts. For example, a charge of the electron. Charge of the electron. We see it in electromagnetism. We see links from this chapter, for example, from this article, to quantum physics, which also deals with electron, and to the Bohr's model of atom. But we have no such source of information. So what are other proofs that prove actually that there are really some mistakes in the modern physics? First of all is that the most evident fact is that already 30 years long, all the scientists, they try to create some generalizing theory, the theory of all, but they cannot do it, and until now there is no success, because different parts of physics, they conflict with each other. And the more you know about some puzzle, the more you know about some problem, then it's easier to complete the task, easier to finish this puzzle, this riddle. But we have the opposite situation. The more the so-called development takes place, the more difficult it becomes to make these parts of physics not to conflict, to bind them in some general system. Also, what are other proofs that there are mistakes in modern physics? Okay, this is the so-called standard model. This standard model, it's a table that shows the energy of the fundamental particles, such as electron, quarks, for example, Fermi, true quark, gluons, tau, neutrino, and stuff like that. These are fundamental particles from which all our universe is built, but the energy of these particles do not show any particular system. For example, electron, it has energy 500,000 of electron volts per second squared, and the true quark, it has 173 billions of electron volts. So there is no system, and it's obvious that there is a mistake, or in the principal scheme of creation equipment and devices to measure this information, or there are more deep and more serious mistakes somewhere in the theoretical level of these studies. Also, in modern physics, as you know, there are three types of units that we use. One of them signify some real aspects, for example, length, for example, amount of matter, or for example, a number of the number of atoms, number of molecules in some particular crystal. Also, there are so-called combinational or combinational units. For example, temperature. Temperature is just a mean free path in real world of molecular in some substance. But we do not use nanometers or picometers to measure these, to express temperature. We use grades of Celsius or grades of Kelvin. But these units are just conventionals, and they mix in them inside of this unit real aspect, real units, and informational units. Units just made to make calculations easier. And the third type is informational calculational units. They are, I think, 90% of all the units that we use. For example, momentum, it is kilogram multiply meters squared divide by seconds squared. Of course, in real world there is no such unit. We have created it to make our calculations easier. But in different chapters and different parts of physics, some informational calculational units were treated. They came into further calculations in further theories as real ones, and that was a mistake. It was a great mistake, and I'll show later to what terrible results it has led. And also such an argument I can show you. It is very simple chain of logic, indeed, that proves that there are some deep and fundamental errors and mistakes in modern physics. For example, we have proton. We have a molecule of water that consists of such protons and other neutrons and electrons and stuff like that. So, proton has a list of properties, list of attributes, but the molecule of water has more attributes and more properties because of it is more complex, more complicated system, the system of the higher level. So the number of laws which act in the molecule of water is greater, and the number of properties is greater than in the proton. Also, we take a drop of water, then we take a wave, sea wave, then we take a sea, and then we take a world ocean, the world ocean. And of course there are much more, different laws and different relationships between the parts of elements in the world ocean than in the drop of water, than in the proton. But in modern physics, the smaller and more basic particles become, the more attributes they have. And now already all these basic particles, they are clever like a Swiss watch, they are clever like computers, and they are more more intellectual particles than, for example, a stone or a crystal or a planet. So it just cannot be. It breaks the logic. It just proves us that there is some deep mistakes in just the attitude. So the last small proof that I want to give you in this video is that there is such so-called law of normal distribution or normal dispersion, or it's also called Gauss distribution or Gauss dispersion. It's a very simple law. It states that if there are elements in the system, after the long time, all these elements or all these energies and pieces of energy and quanta and stuff like that, they would be distributed, they would be dispersed in this system equally, uniformly. For example, all the salt in the water, for example, in the glass of water, would be distributed equally and uniformly in it. For example, if we have, for example, sand on the river bank, then pieces of sand, grains of sand, they would be distributed also equally and uniformly throughout the bank. So, but as we look at the universe, when we look at the universe, we see that not at the level of planetary systems, on the level of galaxy, on the level of local groups of galaxies, on the level of filaments and voids, matter of the universe does not show us this uniform equal distribution. This is also called the end of greatness problem. So when matter stops to be organized in larger and larger blocks and systems and starts to be distributed in space equally, and we cannot find this level and we cannot see it. Obviously there is some fundamental problem in this, but modern physics, the modern scientists, they watch ahead, they look ahead, they search for new discoveries without understanding and without awareness that indeed they should look back because of the mistakes were made previously, and there are mistakes and errors that should be fixed before you can go further. And because of that, our scientific progress became not so fast. So till next time.